Go look at the graphs of these root functions that we've been talking about and working with. Okay, what do these look like graphically? You know, quadratic functions, those are parabolas. Okay, cubic functions, when you start to get x to the third, you know, they can kind of look like that. Maybe sometimes have little hills and valleys in them, local maxes, local mins, things like that. Okay. What do the graphs of radical functions or root functions look like? Okay. So that's what we're looking at today, graphing root functions and finding their key properties. This should be simple. We're doing this essentially in advanced math too. So, okay. So that's our learning target. Everybody got that? Graphing root functions and finding their key properties, specifically domain and range when I say that. Okay, so learning target 6.3. The first thing we're going to do together is we're just going to graph y equals the square root of x. Okay, we're going to graph y equals the square root of x. That was my original problem right here. Okay, that's what I wrote on the board to start. Graph y equals the square root of x. Anytime you're asked to graph something, there's two options. Use your handy-dandy graphing calculators, okay? Or, because this is a pretty easy function, we could just make a table of values mentally, too, with our brains. All right, we're smart enough, okay? Plug in a number for x and see what you get for y. What are some nice numbers to plug in for x where you'll get nice answers for y? 4. 4 is pretty nice, right? What's the square root of 4? 2. So if you plug in a 4 for x, out comes a 2 for y. What's another one? Plug in a 9 for x, out comes a 3. Plug in a 1, out comes a 1. Plug in a 0, out comes a 0. Plug in a negative 4. Not real, right? Because what is the square root of negative 4? 2i, right? Okay, that's not real. All right, we can't plot that point, okay, on a real Cartesian coordinate xy coordinate graph. Okay, so you're not even going to be able to plug in negative numbers for x. So we made a mental table of values. Could you get this table of values off your graphing calculators table? Yes. Okay, but you can make them mentally too. So then I plotted those points, so 4, 2, 9, 3, 1, 1, 0, 0, and there weren't any negative numbers, so I know it just kind of stops right there. Okay. Obviously it keeps going. 16, 4, 25, 5, and so on. Okay. It continues to increase slowly, but it's increasing. Okay. So here's the graph of your square root function. Every square root function is basically going to have that general shape, okay? Every square root function is basically going to have that shape. I kind of think of it as kind of half of a sideways parabola, okay? A sideways parabola would be a U like this, right? That's like half of that. The reason you won't have a full sideways parabola, per se, is because that officially will not be a function. It wouldn't pass the vertical line test if you did have a sideways parabola, okay? So it's just the top half of a sideways parabola in this case. So every square root graph is going to have this general shape. It might be shifted left or right or up or down or increase a little bit faster or increase a little bit slower, okay? But every square root, in fact every even root graph is going to have this general shape, okay? Questions on drawing the graph. Domain and range. What is domain? X values. What x values does this graph touch? Only positives, and along with what number? 0. So would you guys agree that this graph only touches x values from 0 all the way to infinity?
Yeah.
Does that make sense with what you're seeing? If not, let me explain it differently. This graph, what x values does it touch? X values mean this way, right? So the x values this graph is touching is everything from 0 and it goes to the right, goes towards positive infinity, goes forever. Touches every x value.
What about like 3? It doesn't touch 3.
Sure it does, right there.
Just good enough point.
I don't know what the y value is there, but doesn't it touch an x value of 3 right there? Think x values, very important, okay? A lot of people make that mistake. You got to be thinking x values, okay? Now, yeah, we only wrote a couple x values down here in this table, but these aren't the only x values in the domain, right? You know, the graph does not just consist of those 4 dots and that's it. It's a continuous graph. It touches every x value. Does that make sense, Luke?
Yeah.
Okay. Another way to think about it is, what numbers can you plug in for x? 0 and anything bigger than 0, right? I mean, I doubt you're going to plug in 4.67, but can you plug in 4.67 for x and get an answer? Yeah, won't be a nice one, but you can do it. Can you plug in negative numbers for x and get answers? No, because you can't do even roots of negative numbers. Good. Okay. All right, so my domain is every number from 0 to infinity, so here's how we write it. Domain, every number from 0 to infinity. A square bracket on the 0 because it actually touches 0. A parentheses on the infinity because it never actually reaches infinity. It gets really close to infinity but never gets there because you can't get to infinity. All right, that's a concept. That's a value you're approaching, but you never get there. Okay? We do a closed bracket because it actually touches 0. The closed or the square bracket is kind of like a greater than or equal to as far as on a number line, you know, whether you make it a closed circle or an open circle. Okay? This square bracket is kind of like a closed-in circle, meaning it actually equals 0 at some point. So the numbers in my domain would be every number from 0, including 0, all the way till you get to or approaching infinity. This is called interval notation. Okay? From here to here. From small to big. Okay? So the domain of this function is 0 to infinity. The range in this case happens to be the same thing. Range is your what values? Y values. What y values does that graph touch? Does it ever get any lower than 0? No, it never goes below 0 anywhere, right? What other y values does it touch? Well, everything, because the y values just keep on getting what? Bigger. Slowly, but they're getting bigger. Okay? So in this case, my range is also 0 to infinity. So the domain is 0 to infinity, the range is 0 to infinity. Questions? How's my time, Ben?
You're at 8 minutes.
8, okay. Questions right now on this? Okay. I had the other class do one more. I'm going to go quickly through this so I can kind of get it all in one video here, guys. I'll come back to it, though, if I need to. I had them graph y equals the square root of x plus 2. Some of them made a table of values mentally. Some of them went to their graphing calculator and pulled a table of values there. And here are the coordinates they got. Negative 2, 0, negative 1, 1, 2, 2, and 7, 3. And then here we drew our graph. Okay? Could you guys, either mentally or with a graphing calculator, come up with those coordinates? Do you have any questions on that? Could you type it into your graphing calculator, or could you just pick numbers to plug in for x? Okay? You guys should have gotten pretty good with those last semester. So here's the graph. Now, take a look at the domain and range. They're a little bit different this time, or one of them is. Which one's different? The domain. Why?
Starts at negative 2.
Well, what x values does that graph touch? Everything from negative 2 to the right. See how it touches the x value negative 2, and then the x values just keep going forever to the right? So that means my domain is every x value from negative 2 all the way to positive infinity. So that's why I wrote my domain value as negative 2 to infinity. The range happened to be the same this time. Because what y values does this graph touch? 0 on up, right? So from 0 all the way to infinity again. Okay? So there's the graph of y equals the square root of x plus 2. Really, it's the exact same graph. It's just been shifted where? 2 to the left. Should start to relate to some things we've done in the past. Remember the absolute value graphs that shift left, right, up, and down? Remember how a plus 2 inside the absolute value bars shifts it left 2? Same concept. Okay? Let's say you have a square root function that looks like this. Could you identify your domain and range? Well, what x values does this graph touch? Well, the x values it touches is everything from -2 to the right. Excuse me, +2, sorry, I said that wrong. This touches every x value from +2 to the right. So my domain would be from +2 to infinity. What y values does it touch? A lot of people in the other class said -1 to -infinity. Which is correct, just say it in the right order. Because I always want to go smallest number to bigger number. What's smaller, -infinity or -1? -infinity is the smallest number. So we say my range is every number from -infinity all the way up to -1. So that would be the domain and range of this graph. Based on, you think anybody could give me the equation of that graph? Based on how far it's been shifted and which direction?
Square root of x minus 2.
There's going to be a square root of x minus 2 in there because it's been shifted to the right 2.
And a +1 at the end.
Nope. Almost. At the end, it shifts it up or down what you would think would happen. So -1 at the end because it's been shifted down 1, but also instead of being this way, it's this way.
So it's a negative happening there.
Throw a negative right there. Not bad. That is the function that would represent this graph. Okay? So, I didn't get to my last thing that I want to do, a cube root function. I'll have to pick that up a little bit tomorrow. Okay? Go ahead and pause if you haven't yet. Take a look at the